This this is the quiz we had for chapter 8, and as you know, there were some technical difficulties with the Zoom classroom. I really want to make sure everybody had a chance to look at some of the suggestions that I gave to improve your efficiency on the front part of this quiz. So many people were able to get the correct answers, but they're doing a tremendous amount of work that we would like to minimize. So I'm going to go through these efficiently as possible, and I hope that you can take a look at your own quiz and see maybe some differences if you have the need to improve your efficiency. So this first problem, the area of the trapezoid is given. We have to find A. So we know that A plus 50 divided by 2 times the height is equal to 864. So 2 goes into 24 12 times. So we have 8 plus 50 times 12 equals 864. Divide by 12. Be great to keep practicing that short division. 12 goes into 12 times 7 is 84. So 84 from 86 is 2, so the remainder is 2, and then 12 goes into 24 twice. So 12 into 864 is 72. A plus 50 equals 72. Subtract 50. And your final answer is 22 meters. This one over here wasn't a lot of struggle on, but just in case, 144 equals half the base times the height. We're finding the height. Again, just continue to work on efficiency. I'm seeing so much work that some of you are doing to make this much harder than it has to be. 2 goes into 18 9 times, so 9h equals 144. Divide by 9. 9 goes into 14 1 time, and the remainder is 5. So 9 times 6 is, oops, sorry about that. Yep, there we go, is 54. So the 9's cancel out. And the height is 16 centimeters. Let's look at the next problem. On the next problem, we're going to zoom in here so you can see a little bit better. Since this figure is not a right triangle and you don't have the lengths of all the sides, the easiest way to do this is figure out the area of the square. It's a 12 by 12. And subtract out the area of these 3 triangles. So for example, there's 3 different size triangles. And it may be difficult to see that this is 6 0, so this is 6 and 6. So this is a 6 by 7. That makes this 5, so this is a 5 by 12. And this is a 6 by 12. So 144 is the square. And we want to subtract out the area of the triangles. So hopefully you can see that the area of this triangle is just 30, because 5 times 12 is 60, and we take half. And that's what I'm hoping to see on your tests, that you are doing some of this simple math with mental math. So the area of this triangle is 21, and the area of this triangle is 36. So we're just subtracting out all of that. So however you want to take the next step is up to you, but you could just do it in pieces, or you could, you know, use some mental math, whatever works best for you. If I subtract here, maybe you do a little bit of that. It would be fine to jump from this right here to your final answer. It's an area problem, so we're in square units. This kite problem is one that I really wanted to spend a little more time with everybody on. Kites, you know, there's a lot of symmetry in the kite. And if you think about the kite here, and look at this rectangle here, if you could just visualize that this triangle, if I were to take it out of the picture and rotate it and flip it, it fits perfectly in there, as does this top triangle. If I were to take that out of the picture, and just flip that and slide it over here. So in essence, if you think about it, gotta move this. I can just rotate that. And so one way to figure out the area of a kite is just figure out the area of the rectangle that's associated with the kite. And that is just 8 from up here by 21. So 168 centimeters squared. Just pause that for a minute. Okay, sorry for that pause. There was somebody just walking in the room here. So, not sure where we left off. So we were talking about the kite and finding the area of the kite using the idea of a rectangle. And then this last problem, so I know the obvious solution is to add up like the triangle and maybe a square, subtract out the circle and add a trapezoid. And there's nothing wrong about that. But I think one of the more efficient solutions is to use the surrounding strategy. and just keep it like simple if you can. So we have this rectangle, that was weird, which is 16 units by 8 units. That's the entire rectangle. And that, then we have this triangle here, which is 16 units. And we have this little triangle here. And since the entire distance here is 8, that's 4 by 4. So this is half of 16, which is 8. And then we have the radius here to be 4. And we know that because of the 8 up here. So the area of the semicircle, the whole circle, would have an area of 16 pi. So the area of this is 8 pi. And so we can take this rectangle with an area of 128 and subtract out the 3 other parts, the triangle, the other triangle, and the semicircle. And so that would just be 128, take away 16, take away 8, take away 8 pi. And that, these subtract to be 104, take away 8 pi. And that is your final answer in centimeters squared. So it's just an efficient way to do the problem. And then in class, I know that we already talked about the dimensional analysis. So I'm going to post those solutions also and post this video with them.